We humans are rather curious beings, always peering into and questioning our very world itself. Physics, from the Greek physike, is translated as the knowledge of nature. Physics is a branch of science that is concerned with the nature and properties of matter and energy. It ranges from questioning the movement of celestial bodies all the way to trying to understand the smallest scales of energy in subatomic particles. In this video, we shall explore the different branches of physics in order for you to have a better understanding or at least newfound interest in all that this field of science has to offer.
First, we shall talk about classical mechanics. Classical mechanics is the study of the motion of bodies, including when bodies remain at rest. Sometimes also considered Newtonian mechanics in reference to Isaac Newton himself and his laws of motion. The first law is the law of inertia. An object either remains or continues to move unless acted upon by another force. The second relates force with mass and acceleration. And the third states that for every action there is an opposite and equal reaction. The next branch of physics is called thermodynamics. Thermodynamics deals with the relation between heat and other forms of energy. The three laws of thermodynamics are: first law, also known as the law of conservation of energy, which states that energy cannot be created nor destroyed, only transferred or changed from one form to another. The second law states that the entropy, degree of disorder or randomness in the system, always increases. And the third law states that the entropy of a system approaches a constant value as the temperature approaches absolute zero, 0 Kelvin, or around negative 273 degrees Celsius. And with the exception of gases, the entropy of a system at absolute zero is typically close to zero. Another branch of physics is electromagnetism, which studies the electromagnetic force that deals with electric fields, magnetic fields, and their interactions. The electromagnetic force is one of the four fundamental interactions or forces in nature. With the understanding of the force through Faraday and Maxwell's equations, electricity became something we could harness, and this completely revolutionized humans' capability of technology. It is the reason why our phones can do what they do or why light bulbs turn on when you flip a switch. Relativity is a separate branch of physics. Pioneered by Albert Einstein, relativity encompasses a relationship with electromagnetism and mechanics. First, we have the theory of special relativity, which postulates that the laws of physics are the same for all observers in uniform motion relative to one another, and that the speed of light in a vacuum is the same for all observers regardless of their relative motion or the motion of the light source. This theory helps expand on problems that arise from only having classical mechanics and also gives rise to other physical phenomena such as time dilation, length contraction, and arguably the most famous physics equation, E equals mc squared, the mass-energy equivalence. Einstein's other great theory, the theory of general relativity, is the geometric theory of gravitation. It generalizes special relativity and Newton's law of universal gravitation, providing a unified description of gravity as a geometric property of space and time. Quantum mechanics is a rather recent branch of physics that deals with the smallest scales of energy levels of atoms and subatomic particles. Quantum theory typically permits only probable or statistical calculations of the observed features of subatomic particles understood in terms of wave functions. Another branch of physics is optics and atomic, molecular, and optical physics, which deals with the study of light and the instruments created to use or detect it. It also studies light-matter interactions at the scale of one or a few atoms and energy scales around several electron volts. Condensed matter physics is also a branch of physics. This one pertains to macroscopic and microscopic physical properties of matter, specifically when in a condensed phase, where the number of items in the system are extremely large and the interactions between the items are strong. Also, as a branch of physics, high-energy particle physics and nuclear physics studies the nature of the particles that constitute matter and radiation in the atomic nuclei, giving us discoveries such as nuclear power and energy and the Standard Model of particle physics. Lastly, we have cosmology. This branch studies the origin, evolution, and eventual fate of the universe. Modern physical cosmology is dominated by the Big Bang theory, with dark matter and dark energy known as the lambda CDM model. No matter what branch of physics you consider, our knowledge about nature and reality is increasing. We still have many unanswered questions, but physics is a tool that is working hard trying to understand all the interactions we can, and one day even hoping to connect it all.